Eeny, meeny, miny, moe, catch a tiger by the toe. If he squeals, let him go. Eeny, meeny, miny, moe. Everyone knows this rhyme. If Mo lands on you, you win. So who should go first? I think the answer to that depends on how many players there are in the game. What day is it? Today is Tuesday. Jacob knows that his maths test is going to be in 17 days. What day of the week will his maths test be on? Pause the video and have a think. Friday. Jacob's test will be on Friday. Today is a Friday. Janet knows that her mother's birthday is in 241 days. What day of the week will her mother's birthday fall on? Pause the video and have a think. Monday. Janet's mother's birthday is on Monday. When is minus 270 congruent to 90 congruent to 450? When is positive 180 congruent to negative 180? When is 360 congruent to 0? Maybe you guessed it. When we're measuring angles around a circle, such as when we did rotation earlier in maths this term. When is 0 congruent to 12 congruent to 24? When is 8 congruent to 20? When is 9 plus 6 congruent to 3? On a clock. When we're measuring time, the position of 0 on a clock is the same as 12 and the same as 24 hours. 8 p.m. is also known as 20 o'clock in 24-hour time, and 6 hours after 9 o'clock is 3 o'clock. I think we're used to our clock system using a cyclical numbering system. Which brings us to our topic of modular arithmetic. Let's start with an example. If today is Monday, what day of the week will it be in 9 days' time? Well, after 7 days, it'll be Monday again. So we really only care about those extra 2 days, the 7 plus 2 to make 9. It's that remainder of 2, which tells us to add 2 to Monday, which takes us to Wednesday. If today is Monday, what day of the week will it be in 39 days? Well, there are 7 days in a week, so we need to divide by 7. 39 divided by 7 is 5, with a remainder of 4. So we add 4 days to our Monday, taking us to Friday. Numbers that have the same remainder when divided by 7 are said to be congruent modulo 7. For example, the numbers 4, 25 and 39 all have remainder 4 when divided by 7. We can say 25 is congruent to 4 mod 7 and 39 is congruent to 4 mod 7. Note that since 25 is congruent to 4 mod 7 and 39 is also congruent to 4 mod 7, then it must be true that 25 is congruent to 39 mod 7 as well. But we tend to replace a number with its remainder. The number 7 in the problem above is called the modulus. When we divide by 7, the only possible remainders are 0, 1, 2, 3, 4, 5, and 6. Mod 5. We can extend this notion by using a different modulus. For example, if we work in modulo 5, that is, we take 5 as our modulus, then the statement 38 equals 7 times 5 plus 3 tells us that 38 is congruent to 3 mod 5. The only possible remainders in modulo 5 are 0, 1, 2, 3, and 4. Find the remainders of these numbers when divided by 5. Which of the numbers in part A are congruent modulo 5? So when we divide each number by 5 and we get a remainder, the ones that have the same remainder are going to be congruent to each other in modulo 5. 12 can be written as 2 lots of 5 plus 2, which means 12 is congruent to 2 mod 5. 16 can be written as 3 lots of 5, which is 15, plus 1. So 16 is congruent to 1 modulo 5. 18 is 3 lots of 5 plus 3. So 18 is congruent to 3 mod 5. And we can continue this for larger numbers too. 2004 is 400 times 5 plus a remainder of 4. So 2004 is congruent to 4 mod 5. 196,351 is 39,270 lots of 5 plus 1. And so 196,351 is congruent to 1 mod 5. If we have a look at the above results, 196,351 and 16 both have the same remainder of 1. So they are congruent to each other mod 5. Which of these numbers are congruent modulo 2? Show that even numbers are congruent to 0 mod 2 and odd numbers are congruent to 1 mod 2. For part A, we'll start by dividing each of those numbers by 2. 24 is negative 12 lots of 2 plus 0. So negative 24 is congruent to 0 mod 2. Negative 7 is negative 4 times 2, which is negative 8, plus 1, bringing it back up to negative 7. So negative 7 is congruent to 1 mod 2. 6 is 3 lots of 2 plus 0. So 6 is congruent to 0 mod 2. 9 is 4 lots of 2, which is 8, plus 1 more. So 9 is congruent to 1 mod 2. And 244 is 122 times 2 plus 0. So 242 is congruent to 0 mod 2. As you can see, minus 24, 6 and 244 are all congruent to 0 mod 2 because they all have the same remainder of 0 when they're divided by 2. Minus 7 and 9 are both congruent to 1 mod 2 because they both have a remainder of 1 when divided by 2. So you may have seen the answer now to the second part of the question. All the even numbers are multiples of 2, so when you divide them by 2, you get a remainder of 0. So they're all congruent to 0 mod 2. On the other hand, with odd numbers, if you divide them by 2, you'll always get a remainder of 1. So every odd number is congruent to 1 mod 2. Copy and complete the statement below by filling in each of the spaces using the appropriate remainder in the second place. 27 is a certain number of 8s plus some other number. And we're working in mod 8, that's why there's a multiplication by 8 there. So let's think about it. 4 8s are 32, that's too big. Let's try 3 8s. 3 8s are 24, which is smaller than 27, so 3 times 8 is 24. We need to add 3 more to get to 27. So 3 times 8 is 24, plus 3 is 27, which means that 27 is congruent to 3 mod 8. Try these questions on your own. They're also on Canvas, so you can do some more of them. Go through questions 1 and 2, and also 10 through 14. And when you've done this, take the Canvas quiz.